it's spinning, and eventually you get all the way back to the Big Bang, and you start to wonder, you have to start to wonder what is the source of the energy that makes all things what they are, that makes the atoms, and all this. And, in my paper, what I show is that most likely that source is the vacuum itself. It's the space. All of the material world is mostly made out of space, 99.9999999%. What we call the material world is 0.00001% of what's actually there. So, and we know that the space is full of this energy. We call the zero-point energy, or the Planck's density, the fluctuation of the vacuum, and that it's incredibly high. The density is incredibly high. And so when we think of empty space, we're really having the wrong concept. Space is not empty. It's completely full. And what I'm saying is it feeds everything we see, that like the atom is an epiphenomena of the vacuum energy. And, if that's true, and if we understand how the vacuum flows to produce the material world, well, you can imagine the technology that can come out of that.
Mm-hmm. So, Nassim, let me talk about an interesting experiment conducted some years ago. Have you ever heard of Boyd Bushman?
No, I don't think so.
Well, Boyd Bushman, today he's a retired Lockheed scientist. And a few years ago, he was interviewed by David Sereda. And there's a video out there describing Boyd Bushman's experiment. And he experimented with gravity, at Lockheed. And he described this experiment to David, and the people out there, listeners out there, can go and Google Boyd Bushman and with David Sereda. And in this video, Boyd describes his experiment. And what Boyd did is that he took two magnets, two neodymium magnets, and he forced them together. In other words, the poles were either north-north or south-south in configuration, and he took these two magnets and he forced them together. And then he wrapped them up to look like a rock, and then he took his other sample, which was an ordinary rock he probably picked up outside somewhere, and then what he did is that he conducted an experiment. This was back, I think, in the mid-'90s at Lockheed down in Texas. And he proceeded to drop these two rocks, and every time he dropped these two rocks down an elevator shaft, he observed that the rock that had the opposing magnets, these powerful neodymium magnets, fell slower, compared to his control rock. And every time he did that, he repeated the experiment. I think it was like 9 times. And every time he did that, he reported that the rock with the opposing magnetic field fell slower. So he gave a brief description of what was going on there. And I ended up replicating his experiment and observed the same thing. I videotaped it over here in Sedona, Arizona, and I observed that the opposing magnetic field of this of these magnets, it fell slower.
Yeah,
very interesting.
And that's very interesting.
Oh yes.
Because the solution that I give to Einstein's field equation with torque and Coriolis effect in it, so that space-time is not, how Einstein's equation said that gravity is the result of space and time curving or bending? Like if you have a mass in the middle, like a big heavy ball, and you throw it on top of a trampoline, the surface of the trampoline will curve, and another ball will be, tending towards it on the trampoline. So that's basically what he said. And what I added to his equation is that the surface of the trampoline is not smooth, that it has torque, it has Coriolis effect in it, that it has ripples in it, and it forces everything to spin. And so when you do that, eventually you come to a model of black holes where it's not a smooth sphere, but it's actually a double torus. A torus is like a donut, with a hole in the middle. And it's a sphere with two toruses in it and vortices, like big vortex at the north and south pole meeting in the middle at singularity. And so that's the solution called the Haramein-Rauscher solution. And this new approach produces like a double torus kind of structure that bends space and time. And when you put two opposing magnets together, you basically produce that same structure. So that might be why it seems to have an effect on the gravitational component.
Well, Nassim, I took Boyd Bushman's experiment one step further, okay? Oh. And I repeated the experiment, except this time I took two neodymium magnets in an attractive configuration, okay, taped them up and, make it look like a rock, and then I dropped it with my ordinary control rock, and I observed that when these powerful magnets are in attractive configuration, it fell faster. Okay, then the control rock. Right. And I have that on videotape.
Wow, very, very good. Very good.
Oh, yes.
Yeah. The relationship of the spin of the magnetic field, the relationship of the two magnetic fields should, absolutely, in one direction accelerate, in the other direction repel gravitational fields from the Earth.
Now, on Bruce De Palma's website, okay, there's an experiment described using gyroscopes. Okay, right. And what was discovered is that when you take a spinning gyroscope, okay, and drop that, it was discovered that spinning gyroscope fell faster. So, right. There's, compared to a non-spinning gyroscope.
Right. He was doing it as well with bushings, large bushings that he was spinning at high speed, and then he was popping them up in the air. One was spinning, one wasn't. And they didn't have the same curve in the air if it was spinning. So what would be interesting would be to take those two magnets and spin them as they fall.
Yes, exactly.
Yeah.
And you know what I did? Okay, maybe you have heard of the Nazi Bell device. Okay, this is what the Germans developed back in World War II.
Yes.
Okay, I have a model of this Bell device. Okay, that I'm theorizing that you take that the Bell device that the Germans developed were counter-rotating opposing magnetic field device. Mm-hmm. Okay, just what you said. That you take these opposing magnetic fields and then you counter-rotate them. Okay?
Right.
So the idea is to cancel out spin, and when you cancel out angular momentum, because I came to the conclusion that angular momentum is related to gravity, which is a torsion, some sort of a torsion field effect. And that when you introduce counter-rotation,
the Haramein-Rauscher solution
yes.
that as well shows that spin angular momentum is intimately related to gravitational curvature.
Absolutely.
Yes.
I think our research, we have some common ground here.
Yeah, absolutely. I think a lot of people are finally coming to those conclusions, and it's remarkable. It's popping everywhere, and that gives me a lot of hope for our society.
Yes, absolutely. Well, it means